In this video, we will learn about the very important, the most important concept of class 12th, that is continuity, and this is the starting of the calculus part. So let's first of all start with the literal meaning of this word continuity. What is the English meaning of the word continuity? Continuity means anything that goes on. Mathematically, we say if I can draw a curve or anything without lifting my pen, we say that curve is a continuous curve. That is the graphical definition. Similarly, if you observe it over here, suppose I have a curve like this and suppose I have a curve like this. So over here, what do we observe? I am drawing it from here, then I have a gap and then I am drawing it here. Similarly, I am drawing going like this and then I am jumping to this. So it means these curves are not continuous curves. So what are continuous curves? The curves which can be drawn without lifting pen, or the curves which do not have any jumps or holes in between, right? So now if I change it to mathematical definition, then the limits that we did in class 11 comes into picture. So what was the limit? So continuity, the definition is put in three types, like we say, if we say fx is a function and let's say c is a point. So we say as limit x tends to c, fx is equal to the value of the function at point c, then we say the function is continuous. It means if I move from left and if I move from right and the value of the function at any point is also same, then we say it is a continuous curve. Over here, what do we observe? I am moving from left, I have a value. I am moving from right, I have a value. These two are equal, but the value at the point A or C is not equal. Hence, this is discontinuous. The same applies to this. Left value is equal, right value is equal. But the value at point is not equal. Hence, we say that the function is not continuous. For continuity, the value should be equal to the value of the function at a particular point, whatever point we are taking, right? Now, this can be changed. We know limit of a function exists when left hand limit is equal to the right hand limit is equal over here. This is the interpretation of the definition of the limit. Now for continuity, this should be equal to f of c. So we can use the definitions depending on the question and the situation. Then third definition, which most of we do, is x tends to c minus. What does it mean? It means x is less than c. So we can write, we say let x is equal to c minus h. Similarly, over here, x is greater than c, so we can write x as c plus h. So over here, the definition changes as limit h tending, what is h? H is very small value. And since x is less than c means how much it is less than? It is very small, very small value that we can say. It is slightly less than that value. How much? It is c minus h. That h is almost tending to 0. So we say it is f of c minus h is equal to limit h tending to 0, f of c plus h is equal to f of c. So we will be writing, we have these three definitions. It is one and the same definition written in three ways. Different books follow different notations. So what we have, limit x tending to c fx, if it is equal to f of c, we say a function is continuous. In other words, it means I can draw the graph of the function without lifting my pen. Right? Now we know what is continuity. So there are majorly three types of question in this particular topic that we have to do. Mostly a 4-marker question is asked from it. Sometimes you can have a 2+2 division, or sometimes you can have a straight away 4-marker question. Right? So now what we have three types of category. First is continuity at a point. Points will be defined, points will be given to us and we have to check the continuity at those particular points. Next we will have continuous function, where we have to check the continuity in the entire domain of the function. Then third will be the questions where the function is given to be continuous at a point and we have to find the value of certain constant. So these are the three type of questions that we will be doing in this particular topic. First of all, we will start from continuity at point. Question in the category of where the point is given. What the question says, this is question number 1 of NCERT exercise 5.1. It says fx is a function 5x minus 3. We have to check the continuity of the function at point 0, minus 3 and 5 individually. So first of all, I'll check at 0. So we will say at x is equal to 0. So we know the definition, limit x tending to c. C, what is c over here? It is 0, the point fx. So it means what? We will write limit x tending to 0, 5x minus 3. If I put limit x as 0, I can put the value if the function is defined. So it is minus 3 over here. Now what is f of 0? I will directly put the value in the value of the function. So it is coming out to be minus 3. Over here, what do we observe? We will say since limit x tending to 0 fx is equal to f of 0 is equal to minus 3. Hence, the function is continuous at x is equal to 0. I'll apply the first definition here. Why? Because the function at 0 is not behaving differently. For the points which are less than 0 and for the points which are greater than 0, the value of the function is same there. That is why I applied the first form of definition. Similarly, this is at x is equal to minus 3. This is the form of presentation in exam as well. So we will write limit x tending to minus 3 fx. So what is the value of the function? Limit x tending to minus 3. What is function over here? 5x minus 3. So I'll put the value as minus 3. So it will be minus 15 minus 3, which is minus 18, right? Then what is f of minus 3? That is, I'll put in the original function. So it will come out to be minus 18. So we will say since limit x tending to minus 3 fx is equal to f of minus 3 is equal to minus 18. Hence, the function is continuous at x is equal to minus 3, right? So this is the way, this is a feeler question as to know what exactly continuity is. These are the type of questions which will help you to know or memorize the definition. That's it. Then similarly, on the same lines we can do for, we can say at x is equal to 5. The same lines you will be working and we'll get an answer where it will be again. We have question number 2 of exercise 5.1, which again says fx is a function and we have to check the continuity at x is equal to 3. So the same definition I'll apply over here. We will say limit x tending to 3 fx is equal to limit x tending to 3, that is 2x square minus 1. I'll put the value of 3 over there. So 9 into 2 is 18 minus 1 is 17. Similarly, f of 3 I'll get as 17. So we will say since limit x tending to 3 fx is equal to f of 3 is equal to 17. Hence, the given function is continuous at x is equal to 3. Now we have this is a solved example. So I have taken it over here as question number 3. Now what we have, fx is equal to mod x. Now we have to check the continuity of this function at x is equal to 0. Very important mod function. So modulus function, how do we define? We say it as x when x is greater than 0, equal to 0, and minus x when x is less than 0, right? So now over here the second definition will come into picture. Since at the point at which I have to check the continuity, the function is varying. If it is greater than, then it is positive. If it is less, it is minus. And we know if we are putting the limit, it is not the value of the function at that point. It is the value which is less and greater. So that is why for over here, I'll apply the definition 0 minus left hand limit. It means when x is less than 0, what is the function over here? It is minus x. If I put x as 0, my answer will be 0. Similarly, if x is tending to 0 plus fx, then I'll say limit x tending to 0 is positive. So again it is 0, and f of 0, I'll put it in the original function or the place where I have put the equal sign. So it will again come out to be 0. So it means what? We will say since limit left hand limit is equal to right hand limit is equal to the value of the function which is 0. Hence the given function is continuous at x is equal to 0. Next question number 3 of NCERT exercise 5.1. What we have to examine the continuity. As such, no point is given. So function is fx is equal to x minus 5. So what I'll say let c be any real number. I'll say let C be any real number. So over here, if I say limit x tending to C fx, it means what? I'll just put the value of function, which is x minus 5. If I put c in place of x, it will be c minus 5. Whatever is a real number, it can be any real number. I'll get a particular answer, c minus 5. Similarly, what will be f of c? It will also be c minus 5. Since both are equal, it means the given function is continuous, right? Similarly, we will do the second part of the question. I am doing the third part. The third part says fx is equal to x square minus 25 upon x plus 5. X is not equal to minus 5, right? So now what we can do is, again I will say let c be any real number except minus 5. So c is any real number except minus 5. Again we will say let x tends to c fx limit x tends to c x square minus 25 upon x plus 5, which if I solve, I will get as x tends to c x plus 5 x minus 5 by applying the formula of a square minus b square. I will cancel, I will get x minus 5. If I put limit as c, I will get c minus 5. Similarly, if I put in the value of the function, then also I will get c minus 5. So it means what? I can take any value, any real number, the value of the function is equal over here. So hence again it is a continuous question. So these are the simple questions to build up the concept of continuity. Next we will move on to the questions where we have to check the continuity in the domain of the question of the whole function. Okay, D part of the question. Now what we have, mod x minus 5. Again the same question. B part you will try on your own. So what does it says? We have mod x minus 5. So I can rewrite it as x minus 5 when x is greater than equal to 5, and minus of x minus 5 when x is less than 5. Now I have a point 5 around which I will check the continuity. So what we have, suppose this is a whole number line system for the real number, and I have a point over here. I know if it is less than 5, I have a particular function. If it is greater than 5, I have a particular function. So over here, observe very carefully. I will say first of all, let C be any real number. I am saying. I am not saying any point. C be any real number which belongs to this particular part minus infinity to 5. That means all those real numbers which are less than 5. So it can be any real number. It can be like, it can be 4, it can be minus 4, it can be minus 6, any real number. Multiple real numbers you can have. But for all those real numbers, what is my function? My function is minus of x plus 5. So whatever point I take, I will get a continuous function, because limit x tending to c, my function will be what? It will be limit x tending to c minus x plus 5. This c can be any point, like if I say minus 3. So minus 3, left and right will be the same function. So this will be minus c plus 5. Similarly, if I say f of c, it will be minus c plus 5. Both the values are equal. So we will say the function is continuous for all the real numbers which are less than 5. Right? Then we will say this is case 1. This is case 2. We will say let c be real number from 5 to infinity. Right? So it is not 5, but it is greater than 5. It can be 100, it can be 1000, it can be lakh, 10 lakh, any number c. Again, for all these values, the function will be x minus 5. So again I will say limit x tending to c fx is equal to limit x tending to c x minus 5, which is c minus 5. And what will be f of c? It is c minus 5. Both the values are equal. Hence the function is continuous for all the real numbers which are greater than 5. So what we have done? We have checked for all the real numbers which are less than 5 and for all the real numbers which are greater than 5. But we have not checked for 5. So if I say for 5, observe carefully now. Again, very important thing. If I say let c is equal to 5. Now the moment I see c is equal to 5, if we talk in terms of limit says the value is never equal to that point. So what I'll do, I'll say x tending to 5 minus. If c is 5, I'll write 5 over here. So for all the values of x which are slightly less than 5, slightly. Now over here, there is a difference between this and this. Here it is the value of x which is slightly less than 5, which can be 4.99999, any value. But over here, when c is less than 5, it means it can be any number. It can be minus 6, it can be minus 100, any number. So now what will be my function? Over here, what will be my function? My function will be minus of x minus 5. If I put x as 5 over here, what will I get? I'll get 0. Similarly, what will be my right hand limit? It will be limit x tending to 5 plus fx. This is limit x tending to 5. Now if I say 5 plus, it means x is greater than 5. So it is x minus 5. If I put 5 over here, I'll get 0. So this is left hand limit, right hand limit, because we are at point 5 now. So if we are at point 5, we have to check the value which is slightly less than 5, value which is slightly greater than 5, and the value at point 5. So what is my f of 5? So f of 5, if I put over here, it will be 0. Since all the three values are equal, it means the function is continuous at 5 also. So for all the real numbers, this particular function, modulus function, is continuous. Less than it is continuous, greater than it is continuous, at that particular point it is continuous. So this is the second type. A 4-marker question is asked where sometimes a point can be given like this. Then you have to take, these three cases will always be same. First of all, we will take less than, then we will take greater than, and then we will take the value at that particular point. And for that particular point, we will always have left hand limit and the right hand limit, right? Next question what we have, that this is question number 6 of NCERT. Again, exercise 5.1. Question number 4 and 5 can be done on the similar lines as I have explained before. So everybody can try those questions. Now again, what is the heading? What is the question for this particular question? Instead of asking check the continuity, the question is rephrased as find all points of discontinuity. So what we will do? We will check at all the points. At all the point means the points which are not visible even. At those points also we will be checking. So how we will be checking? Again, we will have 3 cases. So how we will do this particular question? We will have 3 cases. First case, we will say let C be any real number which is less than 2. So if it is less than 2, I will say it belongs to open interval minus infinity to 2. So for all these values of C, what will be my function? It will be 2x plus 3 for all the values. The values can again be minus 3, 1, 0, all the values. So again we will say the same thing. These conditions will be same always. Limit x tending to C, fx is equal to limit x tending to C, which is 2x plus 3, and this is 2c plus 3, and f of c is 2c plus 3. Both are equal, hence it is continuous for all the real numbers which are less than 2. Similarly, we will have case 2. We will say let c belongs to 2 to infinity. For all these values, what will be my function? It will be 2x minus 3. I will say limit x tending to c, fx is equal to limit x tending to c, 2x minus 3. So it is 2c minus 3. Again, the value of the function will also be 2c minus 3. Both the values are equal. This will always come out to be equal because we have only one function for all the points. So this will always be continuous. These 2 cases will always be continuous. The crucial point will always be the point at which it is equal to the given point. So this third point is the crucial point. So we will say let c is equal to 2. The moment we say it is equal to 2, we have left hand limit and the right hand limit into picture. So we will say limit x tending to 2 minus fx. So if it is less than 2, what is the value of the function? It is 2x plus 3. The moment I put x as 2, so 4 plus 3 will be 7, right? Then limit x tending to 2 plus fx. So it is limit x tending to 2, that is 2x minus 3. So if I put x is 2, 4 minus 3 is 1. So over here, what do we observe? Left hand limit is not equal to right hand limit, so there is no point of finding f of the value of the function at that point, right? So what do we observe? The left hand limit is not equal to the right hand limit. It means it is not continuous at the point 2. Rest all the points it was continuous. So what was the question? The question was find all points of discontinuity. So why did I do these 2 points? To say that 2 is point of discontinuity, I have to be sure that the rest of the points are points of continuity. That is why we will check the continuity at these points first, and for 4 mark question, we have to show these steps, right? So we will say, since it is not continuous at x is equal to 2, so point x is equal to 2 is the point of discontinuity for this particular function, right? On the same lines, we have question number 7, 8, 9, 10, 11, 12. So we have question number 8. Let's do question 8 first, then we will do question number 7. So question number 8 is fx is equal to mod x upon x, x is not equal to 0. So again we have to find all the points of discontinuity. So before finding the points of discontinuity, if modulus is present in any question like this, we have to redefine our function. So how can we redefine our function? We will say we know the definition of mod x, which says it is x when x is greater than equal to 0 minus x when x is less than 0. So the same definition I will apply over here. Since x is not equal to 0, so it means it will be greater than 0 or it will be less than 0. For 0 it is already defined as 0, right? So now if x is greater than 0, in place of mod x, what will I write? I will write x is already there, it will get cancelled, I will get 1. Similarly, when x is less than 0, I know I can write it as minus x upon x, so it will be minus 1. So we have 1, minus 1 and 0, right? So now I have redefined my function. Now what is the point at which the whole function is centered around? That is point 0, right? So we will again have those 3 cases as we did in the previous question. We will say, let C B belongs to the points which are less than 0. So minus infinity to 0. For all those functions, fx is equal to minus 1. So we will again write limit x tending to c, fx is equal to limit x tending to c minus 1. So it is independent of c, so it will be minus 1. Similarly, f of c will also be equal to minus 1. Hence it is continuous. The same thing we will write for when c belongs to 0 to infinity. We will say fx is equal to 1 over there. So limit x tending to c, fx is equal to limit x tending to c, and this is 1 and this is 1. Left hand limit is equal to, over here for c, then the value of the function at point c is also 1. So both the values are equal, hence it is continuous. I told you before also, for these 2 cases it will always come out to be continuous. The crucial point is always the point at which the function is defined or it is varying. So third point is let c is equal to 0, right? So for c is equal to 0, again we will have left hand limit and the right hand limit. So if I say x tends to 0 minus, so 0 minus means value which is less than 0. So 0 minus is minus 1. So it will come out to be minus 1. What will be the right hand limit? It will be limit x tending to 0 plus. So x tending to 0 plus fx is equal to limit x tending to 0, that is 1. So 1. Left hand limit is not equal to right hand limit. It means it is not continuous at point 0. So what is the point of discontinuity? The point of discontinuity is x. Okay, next we have question number 7. Very important question. It has been asked in board exam couple of times for 4 marks. Now what you can see, we have fx is equal to mod x. 2 points are given, minus 3 and 3. So over here we will have 5 cases, right? So what we will have, first of all, we will say let c be a real number which is less than minus 3. So for all this, over here we can observe it as mod x. Since it is less than minus 3, I can write it as minus x plus 3, right? So again we will say limit x tending to c fx is equal to limit x tending to c, it is minus x plus 3, so it is minus c plus 3. So f of c will also be minus c plus 3, right? Both are equal, hence it is continuous. So this is case 1. What will be case 2? Case 2 will be c is between minus 3 and 3. Now it is less than case we have covered. Now C is between minus 3 and 3. Then what will be my function? Then for all the real numbers, my function will be minus 2x. Again, I write the same thing. That means limit x tending to C fx is equal to limit x tending to C minus 2x, that is minus 2c. Which f of C will also be minus 2c, hence it is equal. Right? Then third case will be, I'll say let C is greater than 3. So again my function will be 6x plus 2, right? So 6x plus 2, again we will have the same thing, limit x tending to C fx, limit x tending to C cx plus 2, which is 6c plus 2. So f of C will be 6c plus 2 and hence both are equal, so it is continuous. So these are the three cases which will always come out to be continuous, but since it is a 4-marker question, so we have to write and we have to present it in this manner. The next case will be, we will check for point minus 3 and 3. Okay, so when x is equal to minus 3, what we will have? We will have left hand limit, that is limit x tending to minus 3 of minus. So if it is minus 3 of minus, it means it is less than minus 3. So less than minus 3 means it is minus x plus 3. If I put the value, what will I get? It will be 6. Similarly, if I say limit x tending to minus 3 plus, so it will be limit x tending to minus 3, plus means greater, so it is minus 2x. So again if I put minus 3, I will get 6. So f of minus 3, I will put in the in the function where I have equal to sign. So again it will come out to be 6. All the three are equal. It means the function is continuous at x is equal to minus 3. Then for 3, again we will do x tends to 3 minus. So 3 minus means it is less than 3. So it is minus 2x. So it will come out to be minus 6. Limit x tending to 3 plus, it means it is greater than 3 now. So we will say x tending to 3, that is 6x plus 2. So it will come out to be 20. Both the values are not equal. Hence the only point of discontinuity in this function is x is equal to 3 point. We can see x is equal to minus 3 is the point of continuity. So the only point of discontinuity is x is equal to 3. So for all the questions where you have 2 points, you will have 5 cases. In the same manner you will be doing. You will try question number 9, 10, 11, 12. Then question number 13 can also be done on the same lines. Question number 14 is also, 14, 15, 16 is also exactly on the same lines. Right?